Everything you love has an expiration date. Your phone, our sun, every galaxy in the sky. And this is the strange part, time itself. Physicists aren't arguing about whether the universe will end anymore. They're arguing about which of 5 endings gets to us first. 5 endings, 1 winner. Tonight we'll walk through all of them. The freeze, the rip, the crunch, and the one so sudden you would never even see it coming. Because it travels at the speed of light. And stay to the end, because the last chapter completely changes how the rest of this video feels. First, the uncomfortable fact this whole story rests on. The universe is not standing still. Every distant galaxy we look at is rushing away from us, and the farther it is, the faster it flees. Space itself is stretching, like dough rising with raisins in it. And in 1998, 2 rival teams measured how fast and found something nobody wanted. The expansion is speeding up. Something invisible is pressing the accelerator. We call it dark energy, which is science speak for we have no idea. The measuring sticks were exploding stars. A certain kind of supernova always detonates with the same true brightness. So how faint it looks tells you how far it is. Map enough of them, and the universe's whole speed history falls out. The discovery was so seismic, it took the Nobel Prize in 2011. And it means the universe's ending is not fixed by the past. It's being decided by whatever dark energy does next. The universe isn't slowing down, it's speeding up. Ending number 1, and the current favorite. The big freeze, death by running out. Stars run on fuel, and fuel runs out. In about 1 trillion years, the gas for making new stars is gone. The bright galaxies you know fade to red, then to embers, then to black. The last stars standing will be the red dwarfs, tiny, frugal suns that can sip their fuel for trillions of years. The universe's final daylight will be a dim red glow. After the stars, the era of black holes, they outlive everything. And then, over numbers of years so large they're basically jokes, even they evaporate into a whisper of particles. If you watched our black hole episode, yes, Hawking radiation gets the last word. After the last embers cool, dead stars become black dwarfs. Objects so cold and dark, the universe has never yet made a single one. There simply hasn't been enough time. Every black dwarf that will ever exist is still in the future. And if protons themselves eventually decay, physics isn't sure, then even that frozen matter dissolves, atom by atom, into faint light and nothing. The universe doesn't end with a bang. It forgets how to do anything at all. Ending number 2 is not quiet at all. If dark energy grows stronger with time, everything gets torn apart. The Big Rip. Right now, dark energy only wins on the biggest scales. Galaxies hold together easily. But if its strength keeps climbing, the tearing moves down the ladder. First, galaxy clusters are pulled apart, then galaxies, then solar systems. In the final months, planets are stripped from their stars. In the final minutes, planets themselves explode. And in the last fraction of a second, atoms and then space itself are ripped open. The good news? For the rip to happen, dark energy has to behave in a very specific, very weird way. And so far, the data says it probably doesn't. Probably is doing a lot of work in that sentence. Ending number 3 runs the movie backwards. What if the expansion turns around? The big crunch. If dark energy ever weakens or flips, gravity gets its revenge. Galaxies stop fleeing and start falling back. The sky grows brighter and hotter and more crowded. The Big Bang in reverse, ending in a single point. Falling inward, all that starlight gets compressed and heated. Long before the final point, the night sky itself glows hotter than a furnace. The stars don't need to hit you. The sky simply cooks. And here's the twist that keeps this ending popular. Maybe a crunch isn't an ending at all. Maybe it's a bounce, a collapse that ignites a brand new Big Bang. A universe that breathes in and out forever. Maybe our Big Bang was somebody else's big crunch. And now ending number 4. The one physicists lower their voices for: vacuum decay. Deep beneath everything, an invisible energy field, the Higgs field, sets the rules for all matter. Our measurements suggest it may not be resting at its true bottom. It may be balanced on a ledge above a deeper drop. If any point in space ever tumbles off that ledge, a bubble of new physics is born, and it expands at the speed of light, rewriting the rules of matter as it goes. Atoms, chemistry, stars, us, none of it works inside. Why suspect the ledge at all? When the Large Hadron Collider weighed the Higgs boson, the number landed almost exactly on the knife's edge between a stable universe and a doomed one. Of all the values it could have had, it chose the border. And because it moves at light speed, there is no telescope, no alarm, no warning of any kind. The last thing you'd ever know about it is nothing. It would simply arrive. You would never see it coming, literally. Before you cancel your plans, the same math says a bubble like that is absurdly unlikely. The universe should stay on its ledge for far, far longer than it has already existed. But unlikely and impossible are different words, and physicists know it. So which ending actually wins? Here's what the evidence says right now. Today's data points to the slow one, the big freeze. But here's the newest wrinkle. The latest sky surveys hint that dark energy might be weakening. If that holds up, the crunch quietly climbs back into the race. The instruments doing the measuring are running right now. Robotic survey telescopes charting tens of millions of galaxies, night after night, rebuilding the expansion history of the universe decade by decade like tree rings. Which means the honest answer is the exciting one. We are measuring the fate of the universe right now, in real time. And the verdict could change within your lifetime. The end of everything is an open case. And now the chapter I promised, the one that changes how all of this feels. Every ending we just toured lives absurdly far away in time. Written as a number, the black hole era ends around 10 to the power of 100 years. If the universe's whole life were a single year, we're living in the first few seconds of January 1st. How far away is 10 to the power 100 years? If you wrote 10 every second, writing out that number takes under 2 minutes. Living through it takes every star everywhere dying trillions of times over. We aren't witnesses to the universe's decline. We're impossibly early guests, alive in the bright, loud, star-making springtime when galaxies still blaze and new suns still ignite every single day. You didn't arrive at the end of the story. You arrived at the beginning. So yes, the universe will end. In ice, or a rip, or a crunch, or a silent bubble. But every sunrise you'll ever see happens in the universe's golden age. And you have a front row seat. Which ending do you find most beautiful? The freeze, the rip, the crunch, or the bubble? Tell me below and subscribe. The story of everything is still being written, and we're reading it together.